Okay, so hello everyone, this is Akshay here, and today we're gonna solve a very important question related in stacks. It's the problem number 84 in LeetCode, the largest rectangle in the histogram, and it's a hard category question, right? So, given an array of integer heights representing histogram's bar height, where the width of each bar is 1, return the array of the largest rectangle in the histogram, right? तो हमें यहाँ क्या करना है यार, हमारे पास array elements दे रखे होंगे which is representing the height of the given towers. हमें उनमें से जो लार्जेस्ट रेक्टेंगल जो फॉर्म हो रहे हैं उनका एरिया निकालना है, राइट? यू कैन क्लियरली सी फॉर दिस टेस्ट केस the largest rectangular area would be this one, and you need to return this area, right? It is, you can say, somewhat similar to our rainwater problem, rainwater trapping. Not exactly, but yeah, there we had some towers and we need to go in left and right, find the lmax and rmax, and then we do the computations, right? हम यहाँ क्या करेंगे यार, हर एक टावर के लिए अगेन कुछ कुछ कंप्यूटेशन करना ही पड़ेगा, राइट? सो लेट अस अज्यूम वी आर एट दिस टावर, एंड व्हाट कैन आई सी इज दैट द लार्जेस्ट एरिया ऑफ यूजिंग दिस टावर I can see is this one. This is the maximum rectangular area that can be formed using the tower height 3, right? Because it should be common in all the given towers. That means that whatever for array of I, what you need to do is you traverse towards the left and towards the right as well, and you found the next smaller element, right? So what is the next smaller element for this 3? मतलब आपको अपने लेफ्ट में जाना है, और जैसे ही कोई एक एलिमेंट मिल जाए इस पर्टिकुलर एरे ऑफ आई जो कि यहाँ पे 3 उससे छोटा, देन डेफिनेटली उसका इंडेक्स आपको रिटर्न कर देना है. So I can see that in the left there is 5 which is definitely greater than 3, so we'll keep on traversing towards left. तो 4 है which is also greater than 3, we'll keep on traversing and we find a value 2 which is actually lesser than 3. So for this thing we are talking about this tower, right? So the NSE, let's say left NSE value would be, for this case, would be index 0. This 2 has index 0, right? And similarly right NSE, that is in the right hand side, what is the next smaller element? Clearly I can see this one, this 2 is there. And what's the index of this 2? It says 6, I guess, right? 0 1 2 3 4 5 6. It is 6, right? Now how can I get the area of the this rectangular histogram? So definitely, what is the area of rectangle? It is length and breadth, right? So I can take the breadth from the height of the given tower, right? So I can say that array of I star. Now what about the length? How can I find this particular length, right? So हमने जो राइट NSE और लेफ्ट NSE निकाला था वो एक रीजन से निकाला था, राइट? हमें इसका इंडेक्स और इसका इंडेक्स मिल चुका है. we'll just subtract the index, so it would be 6 minus 0, करेक्ट? तो इनका जो डिफरेंस है क्या हो जाएगा, बीच में कितने टावर लेंथ है, 1 2 3 4 5, राइट? सो इट वुड बी, लेट्स से हम इसको हैंडल कर लेंगे किसी तरह, 6 माइनस 0 प्लस 1 या कुछ करके, या माइनस 1 करके, एवरीथिंग, राइट? सो अगर हमारे पास दो इंडेक्स आ गए तो डेफिनेटली वी कैन गेट दी लेंथ, एंड विच इज नथिंग बट 5, राइट? एंड व्हाट्स दी, एंड कैन क्लियरली सी दिस इज 1 unit, second unit, third, 4 and 5. 5 into 3 which will give you as 15, and that would be your answer for this particular output input. But definitely हमने सिर्फ अभी एक हाइट के लिए चेक किया, हमें सिमिलरली सारे हाइट्स के लिए चेक करना पड़ेगा, राइट? सो बट यू गॉट द लॉजिक, राइट? हमें करना क्या है, इनमें से मैक्सिमम निकालना है. सो लेट अस राइट द लेफ्ट NSE वैल्यूज, राइट? सो 2 के लिए हम क्या करेंगे, यहाँ पे कोई किसी भी लेफ्ट में इसके पास कोई भी टावर्स प्रेजेंट नहीं है, सो आई विल मार्क दिस एज -1. सिमिलरली फॉर 4 आई कैन सी द नेक्स्ट स्मॉल एलिमेंट would be this 2, and the index of that 2 is 0. Similarly for 5, the next smaller on the left is 4, and the index is 1. For 3 we have already found it. For 6 you can clearly see that the next small element in the left is 3, which has the index as 3. For 7, the next small element in the left is 6, which has the index 4. And for 2, the next smaller element, or let's say less than equals to this element, smaller, we need smaller, not equal. So there is no element in the left for this 2 which is smaller than this given height, that is 2. So I will say -1. I did not find any index, so in that case I will say -1. ठीक है. Similarly आपको right NSE values भी निकालनी है. Okay, so एक बार let us do a quick dry run that how we can find the left NSE's value. And why do we need the index? Because we need the index to get the length of the rectangle, right? Or let's say one dimension of the rectangle. So for the elements, so what you have, the elements 2 5, let me write it down again. Okay, so here we will use a stack, and what will be the properties, and above is the pseudocode we're gonna follow, right? Let us do a quick dry run so that we can understand it more efficiently. Okay, so for this zeroth element, so definitely you have to push the index of the first element, because for the first element the answer is always -1, because uh, there is no towers present in the left hand side of the first tower. So 4, what you're gonna check is what you need. You need smaller, right? So if the peak element in the stack contains the left element, right? So if the peak of the stack, if it is greater, then definitely you have a violation. हमें करंट इंडेक्स में 4, हमें चाहिए इससे छोटा कोई नंबर, राइट? इससे नेक्स्ट स्मॉलर चाहिए। तो डेफिनेटली अगर स्टैक में हम स्टोर कर रहे हैं और उसका जो टॉप एलिमेंट अगर वो ग्रेटर हो जाए हमारे गिवन हाइट से, तो डेफिनेटली वो एलिमेंट नहीं कंसिडर किया सकता। दैट इज व्हाई वी डू अ पॉप देयर। सो लेट्स जस्ट स्टार्ट कंपेयरिंग। So the current element is 4 and we are comparing with index 0 which has the element 2, right? So 2 is lesser than 4, right? So there is no problem. Just paste the index of the topmost element of the stack and push the current index, that is 1. Similarly for 2, what is the element? 5, and the topmost element is 4, which is ensuring that this is the nearest element for your given tower which you are iterating. इस 5 के लिए जो हम iterate कर रहे हैं, ये जो topmost element है ये nearest है और हमें वही भी चाहिए था, nearest smallest number, राइट? तो अगेन ये जो टॉप है इट इज लेसर देन 5, तो कोई प्रॉब्लम नहीं है। जस्ट पेस्ट द इंडेक्स एंड पुश द इंडेक्स एज वेल फॉर द गिवन for the current element. Now for the third index the element is 3 and I can see it is the peak element is greater than my 3, so definitely I have to pop it out. I have to pop it out until and unless I get a element smaller than my current number. So again, so index 1 has element 4 and we are comparing with 3, again it is greater, pop it out. Again for 2, as for index 0 the element is 2, so definitely this will work. Copy paste the index here and push the current index for the next iterations. Now I'm at here, I can see this is 6 and I'm comparing with the index 3 which has the value 3, so it is lesser, no problem. Just uh, mark the topmost index as my answer and push your current index. Similarly for next iteration, you have 7 and you're comparing with 4 which is already lesser, and this is the nearest as well because this is the topmost element of the stack. So just push your topmost element as answer and push your current index into the stack. Similarly for the last element, what we can see that the element is 2 and now this is greater than my topmost index element. I will remove this because this was actually representing 7. Index 4 is also representing 6 which is greater than 2, remove this. Now index 3 is representing 3, so I have to remove this as well. Now this index 0 is representing 2, so it is equal to, right? So for equals to also we have to remove it because we need strictly smaller than my current element. So if stack is empty, then definitely we are marking this as -1, correct? Similarly, you have to find your RNSE and then you just have to compare the maximum area, right? Please pause this video, try to code this RNSE by yourself and try to code this thing as well, that how will iterate for the maximum area for the histogram. Okay, so that's the entire code we have. So we have a LNSE that is left next smaller element. The first index is marking with -1 and we have already explained this pseudocode. We have already seen the driver. Let's just jump to the RNSE. So similarly, once we have marked this -1, so we are marking here as n, right? And we have another stack. So you may यहाँ पे एक अलग स्टैक भी बना सकते थे या फिर ये ऊपर वाले स्टैक को यूज कर सकते हैं, जितने भी अगर रिमेनिंग एलिमेंट्स हैं एक वैल्यू लगा के उसको बाहर कर सकते हैं, बट स्टिल ठीक है, कंटिन्यूअसली सेम ही रहेगी, स्पेस कॉम्प्लेक्सिटी सेम ही रहेगी। एंड वी आर पुशिंग फॉर द लास्ट एलिमेंट, डेफिनेटली उसके राइट में कोई भी टावर्स नहीं है, तो उसके लिए हमने सेम इंडेक्स को पुश किया। एंड we have a for loop going from second last element to the first element, and we are again comparing the same thing which you're doing for the left NSE, you have to do for the right NSE, and again the same thing is happening. And the last, we are just maintaining a max area to keep the track of our maximum area. So what would be the time and space complexity for this code? Okay, so this thing you may be ये एक्सप्रेशन सुनने में कोई दिक्कत हो रही होगी शायद, तो मैं एक बार तुरंत से आपको समझा देता हूँ एक पर्टिकुलर टावर के लिए। So this is what's happening. I have filled the RNSE values, you can try and fill it yourself. And what's happening here is that we are taking the RNSE values -1 and we are taking the LNSE value +1 into the height of the tower. Why we are doing so? Because हमने यहाँ पे इस चीज़ को भी तो हैंडल करना है ना कि फर्स्ट टावर के लिए you have to fill something, right? अगर आपने -1 फिल किया है तो डेफिनेटली सारे इंडेक्सेस को +1 से भी बढ़ाना पड़ेगा, right? So that's a very minor adjustment we have made so that we do not have to write if statement for the last index and the first index respectively, right? Okay, so what is the time and space complexity? So time is again O of n and O of n as your space complexity as well. Again, so what will be the next problem we will be covering it? So next problem will be maximum rectangle, right? This is also a hard question, but this is a very intuitive question. So once you have done this largest rectangle Instagram, do give it a try. It's the same question, you just have to observe something, right? So we have been given rows and columns of binary matrix filled with zeros and one. We need to find the largest rectangle containing only ones and return its area. So we will try run for this particular test case for the smaller one, and once we understood, we will run for all the longer cases as well. So let us go to the board again. So okay, so again the prerequisite here is largest area in histogram. So let us see that how we can boil this down or narrow this down to this problem. So we have so for the first, you need to get the cumulative sum. First is you get the cumulative sum as we move down in the rows. Cumulative sum rows. I'm just writing it like this. And the second is whenever you have a zero, reset your array to zero, right? That's an important part. Okay, so let us look at it again in detail. So for the first row, 0, 1, and 0, you need to draw, you need to find the largest area histogram for this particular row, right? And you can clearly see for 0, 1, and 0, if you manually see, the area would be 2. Similarly, when you move down to the second row, you need to get the cumulative sum. So what would be the sum? So this, if you consider these two rows, then what would be the values? So 1 plus 0 will be 1. Again, 1 plus 1 would be 2. And this third column would be 1 plus 1, again 2 and 1. Similarly, I have written for all the third row and the fourth row. The only thing you need to take care is that when you get a 0 at any point, so you reset that particular point as 0. You do not have to take the cumulative sum for that, right? Okay, so that's the, again, so your next array would be, the second row array would be updated as this, and you need to find the largest area in the histogram, and manually you can see it is 4. Similarly, for the third row it would be 6, and the fourth row it would be 6. You need to take the maximum of these values, and that would be your answer, correct? Now please pause this video here, and since we have already done the code and everything for the largest area in histogram, please try to code this approach by yourself. Okay, so let me give you a very quick code walkthrough. So that's the code. That's the exact code I have copied from the largest area of the histogram. You can clearly see even the inbuilt functions as well. And then here we are just iterating for all the cells in the matrix, and for each and every row what we are taking, we are making an array of size m, and once it is equals to 0, we are marking that particular index as 0. If not, we are just incrementing the sum, and we are taking the maximum, we are keeping the track of the maximum area using the function of largest area, rectangular area of the histogram. So that is it here. So what would be the time and space quantity for this code? Definitely O of n for this for loop and O of m for this for loop, right? So n cross m, and in the parallel it's running largest rectangular area, so it will again take O of n, right? So if I could say the overall time complexity would be O of n cross m, right? And in the parallel it's there, so O of n cross m plus n, you can say like that. But if you ignore the constants and everything, it would be O of n square, right? Or let's say n cross m. And what would be the space? What would be the space? Since we are running the code for area of histogram, so O of n would be required for your stack as well. So that is it. You can see all the code getting successfully submitted. We have covered two things, the largest area in histogram and one of the very good variation of it, which is also termed as hard question in the LeetCode. So yep, let us meet again in the next video. And if you like the problem statement and everything, do like, share and subscribe. The other social media links would be in the description. You can follow them to get the latest updates. Let us meet again in the next video. Till then, keep learning, keep going. Bye bye and take care.